Rotary secondary injection molding is an advanced manufacturing process that enables the production of integrated dual material components in a single operation. This technology combines two different plastic materials, typically a rigid substrate and a soft elastomer, into a high-quality product. Process overview. The process begins with the injection of the first material, usually rigid polymers like ABS, PC, or PP, into cavity A, forming the product structural base. The mold then rotates 180 degrees, aligning the substrate with cavity B. A second material, such as TPU, TPE, or silicone, is injected to encapsulate designated areas of the base component. Finally, the completed part is ejected, ready for use without additional assembly. Key advantages. 1. Enhanced product quality. The immediate bonding between freshly molded materials ensures superior adhesion, while mechanical interlocking features prevent delamination. This results in durable components with seamless transitions between materials. 2. Increased efficiency. By consolidating to manufacturing steps into one automated cycle, the process eliminates intermediate handling and significantly reduces production time. This automation allows for higher output with minimal operator intervention. 3. Design flexibility. Engineers can create products combining multiple material properties such as rigid, structural elements with soft-touch surfaces, enabling innovative designs that improve both functionality and user experience. Applications. This technology is wide-line, employed across industries, consumer electronics, protective cases, wearable device bands, automotive, steering wheels, control buttons, medical devices, ergonomic instrument handles, household products, tool grips, kitchenware handles, economic considerations, while requiring higher initial investment in specialized equipment and mold design. Rotary secondary injection molding becomes cost-effective for high-volume production. The reduction in assembly steps and improved product quality contribute to long-term manufacturing efficiency. This advanced molding technique continues to gain popularity as manufacturers seek to create sophisticated products that combine multiple material properties while maintaining production efficiency and consistent quality.